Hi there, welcome back to another video. This time we're going to be doing something a little bit different. We're going to have a little bit of fun. We're going to show that the sum of all the natural numbers equals minus 1 over 12. Now this is a very controversial result as, well, firstly it's not intuitive. You would think that if you keep adding up all the natural numbers, you would eventually arrive at infinity. Now, disclaimer, some of the maths in this video is fake, so what we're going to be doing is sort of assigning values to infinite series, and you're strictly not allowed to do that. However, in an area of mathematics called analytic number theory, and in particular the Riemann zeta function uses this value, so it does hold some significance in mathematics. Okay, to start with, we're going to consider this sum. Now I'm going to call it SA. We're going to consider 3 series in this video, but this one is basically the alternating sum. So it's 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on, and it continues like this. Now this is actually from a mathematician called Grandi, so if you want to have a look then feel free to do so. Okay, so what we're going to do now is something, again, that's strictly not really allowed, but we're having a little bit of fun, and we're going to derive this result. So we're going to do 1 take away this sum. So 1 take away SA, well, it's 1 take away everything above, 1 minus 1 plus 1 minus 1 plus 1, and so on. And let's just do this. Well, 1, and we're minusing, so everything inside the bracket, its sign's going to be flipped. So we're going to get 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 and so on. Yeah. So what have we actually arrived at here? Well, this thing on the right hand side here is nothing more than what we started with. So it's actually just equal to SA. Okay, so what have we arrived at now? Well, we've now got this equation, 1 minus SA equals SA. So, using some algebra, very basic algebra, we can see that 1 minus SA equals SA, and this tells us that 2 lots of SA equals 1, and so SA, our series, equals a half. So that's our first result. Okay then, so let's consider another series, and this time we're going to call it SB, so it's our second series. And this equals 1 minus 2 plus 3 minus 4 plus 5 and so on. So it's alternating, but the numbers are increasing by 1 every time. Now let's look at what happens when we add SB onto itself. In other words, we're looking at 2 times SB. But I'm going to do it in a slightly strange way. So we're going to have the original. And as you know, multiplication is nothing more than repeated addition. So 2 lots of SB is the same as adding SB onto itself. So what I'm going to actually do is write SB below like this. So plus 1 minus 2 plus 3 minus 4 and so on. Okay, now all we've got to do is work these out. So we've got a 1 minus 2 plus 1 is minus 1, plus 3 minus 2 is a plus 1, plus 1, and so on. So what have we got here? Well, it's nothing more than our series SA, the Grandi series. So 2 lots of our sum here equals the same as our series we started with. Okay, again, using some algebra, we can say that 2SB equals SA. But we know that SA from up here equals a half. So 2SB equals SA, which equals a half, and this implies SB equals a quarter. So that's our second result. Okay, so we now have these 2 bits of information. SA equals a half and SB equals a quarter. Remember, SA was our alternating 1 minus 1 plus 1, and SB was also alternating, but it was 1 minus 2 plus 3. Now let's have a look at this series SC, and this is actually the one we're interested in. 1 plus 2 plus 3 plus 4 plus 5 and so on. So this is the sum of the natural numbers. So I'm going to write sum of all n in n. Right, what happens when we take our SC and we subtract SB? Let's have a look. So we'll write again our original SC, like so. And I'm going to write it down here again. So I'm going to do brackets as well, just so it's extra clear. And our SB was 1 minus 2 plus 3 minus 4 plus 5 and so on. Okay, now this is where, again, the maths is getting a bit crazy. We can't really assign infinite values to series like this, but we're having a bit of fun, and here we are. Okay, so let's evaluate. 1 minus 1, well that's 0. 2 minus minus 2 is 4. 3 minus 3 is 0. 4 minus minus 4 is 8. 5 minus 5 is 0. Then we'd have a 6, so I'll just write it in just for a bit of clarity. 6 minus minus 6 is 12, and so on. And hopefully you should be able to see that this is 4 lots of 1 plus 2 plus 3. And this 1 plus 2 plus 3 and so on is what we started with. It's our SC. Right, we're almost there now. We're about to hit the crazy maths. So we've now got SC minus SB equals 4SC. Again, using some algebra, we can see that 3 lots of SC equals minus SB. And we know what SB equals. It's just a quarter. So move down here. 3 lots of SC equals minus a quarter. And dividing by 3 gives us our result. SC equals minus 1 over 12. And that is an absolutely crazy result there. So, that's it. We've shown that the sum of all the natural numbers somehow ridiculously gets to this value, minus 1 over 12. Hope you enjoyed. Hit the like button if you enjoyed, and see you all next time.